In this video, we're going to look at the remainder of the alternating series. So as a reminder, which you should already know, an alternating series looks something like this. It gets smaller and smaller and smaller and smaller. So when it comes to an alternating series, we always discard the alternating components of it. So we would just concentrate on the UN. We would just concentrate on the UN. So when you concentrate on the UN only, it looks something like this. Because let's say this is 10 here. Let's say this is 10, and let's say this here is negative 7. So from here to here is 10. So let's just say that's from here to here. And then from here to here is negative 7. But because you've discarded the alternating component, then this negative 7 becomes a positive 7. So this here is positive 7. Let's just say this is 5. So this here is 5. This is negative 3. But because you've discarded the negative component, then this negative 3 becomes positive 3. So your graph will end up looking something like this. So when it comes to the alternating series, make sure that it's non-increasing, meaning make sure it's always going downhill, or it could stay the same, but make sure it's non-increasing. And then make sure that the limit equals 0. Make sure it's heading towards 0. You should already know this. We've done this in the past, so this is just a reminder. Before we look at the remainder, let me just remind you of something else as well. When you sum up everything from 1 to infinity, when you sum up everything to infinity, then the whole thing, the sum of the series, we would use it. We would use capital S to denote you summing up everything to infinity. But when you truncate it to, let's say, around here, then this block here is your S sub n. So this is just a notation. When you sum up everything all the way to infinity, we would use S. When you truncate it, let's say up to here, then this block here becomes your S sub n. So if you look at this here, because you're summing up everything to infinity, then you can say the whole thing here equals S. But when you cut it, let's say here, then this is your S sub n. So now this should make sense here, because currently, let's say this here is your S sub n. When you take the limit as n tends to infinity, it means sum up everything to infinity. Then your sub n here becomes the whole series. It becomes the sum of the whole series. So it becomes S. And then if this makes sense, then this also makes sense. Because if you look at this here, S, if you truncate it, let's say here, so this is your Sn here, and then take the limit as n tends to infinity. So n tends to infinity. If you get the whole series, remember, summing up all the way to infinity is your S. But then as this sub n heads towards infinity, then, if this makes sense, hopefully you can see that this makes sense. Okay, so now let's look at the alternating series. So if you truncate it, let's say up to n here, then this block here is your S sub n. So this block here is your, and then you've got a remainder here, you've got a remainder here, and so on. We're just going to say the whole thing here, all the remainders becomes your R sub n. This is just a notation. This is just it's just how we would convey all the remainders. So all the remainders. So you cutting up to here is your S sub n. So all the remainders is this. This here represents all the remainders. So when it comes to looking at the remainder of the alternating series, well, the remainder here, this remainder here, has to be less than or equal to this term. So suppose you truncate it right here. What the remainder is saying is that the remainder, all the remainders here, has to be less than or equal to this one specific term here, this one figure here, So all the remainders here has to be less than or equal to just this value here. So if you look at this, if you look at our example here, so if you this is our S sub n here. If you sum up everything, the first 4 terms, it becomes this. and then you've got all the remainders here. You've got all the remainders here. What this is saying is that all the remainders has to be less than this figure here. Less than this figure has to be less than a fifth. The remainder here has to be less than a fifth. So all the remainders here, if you just look, if you're interested in the remainder, all you need to do is just look at this figure here, and it has to be less than a fifth. And if you think about it, it kind of makes sense, because let's say a fifth from here to here is a fifth, and then if you're just looking at the remainder here, from here to here is a fifth. But don't forget, when it comes to an alternating series, we demand that it's non-increasing, meaning it's always going downhill. So this figure here must be less than this thing here. So if a fifth is from here to here you take away a sixth. Well, taking away a sixth would be less than a fifth. So it won't reach down here. It has to be above that x-axis. And then when you come to add another number, this thing here must be less than this, because when it comes to an alternating series, we demand that it's non-increasing. So this figure here must be less than this. So when you come to add the next figure, it has to be less than the previous one. So it doesn't go all the way back up. It has to be less. And then when you come to take away, this figure here must be smaller than this one here. So it has to be less than this. So it can't go all the way down here. It has to be less than that. And when you come to add the next one, it has to be less than, and it has to get smaller and smaller and smaller and smaller. So what we're trying to say is that when you combine all these together, it must be less than this initial value here. It must be less than this initial value here. So it must be less than a fifth. So what it's saying, the remainder must be less than or equal to whatever figure this. So this is your un here. So and this must be your un plus 1. So all the remainders combined together must be less than or equal to just this one figure here. So all you need to do is look at this one figure here, which is your un plus 1. Okay.